Okay, so what do we got filled in? Looking up there at the top, there's your definition of a polynomial function. Lord, it looks so scary, but it's really pretty simple. Which is the leading term? What do we mean by the leading term? The very first one, right? So a sub n x to the nth would be your leading term. And what is the degree? What do we mean by the degree of a polynomial? Charlie? And yeah, it's the highest power, right? And then the leading coefficient would be the coefficient on the term with the highest power, so that would be a sub n. So for example 1, the leading coefficient is 3, and the degree is 4. Now let's just be clear, there's no questions on the AP exam that easy, but you have to know this vocabulary to answer other questions. Okay, so B, the leading coefficient is, watch it, -7. -7. And your degree is 3. Leading coefficient is, be careful, what's the degree of this polynomial? 0. Right? Okay, so I guess we could go with 4. We'll go with 4 for leading coefficient, because that would be 4x to the 0. Okay, 4. All right. The extrema are the maxes and mins of the function. There are actually 4 types of extrema. There are local, sometimes called relative. Have we talked about this already? No? Okay, so we have local or relative. And then we have global or absolute. Okay, so these mean the same thing. It's just 2 vocabulary words for the same thing. These mean the same thing. But both of these can have a max or a min. Okay? So let's look at that first picture there. Relative extrema, local. A polynomial has a relative minimum or relative maximum where it switches between decreasing or increasing, or at an endpoint if the polynomial has a restricted domain. Okay? So, where do you see local minimums or maximums in that picture? Well, at -4, you have a minimum. That is an endpoint. And endpoints count if you have a restricted domain. So you have a local minimum at -4. What do you have at -2? A local maximum. What do you have at 0? A local minimum. And what do you have at 3? A local maximum. Okay, so you okay with that? Now notice the arrow on the right side of the picture. There aren't any maxes and mins there because that guy is going forever, right? Now, absolute or global means you are the absolute highest point on the picture or the lowest point on the picture, okay? So looking at your same picture there, where is your absolute maximum? So x is 3, and the value of the absolute maximum is 2, right? The highest point is 2, and that happens where x is 3. And then how about absolute minimum? We actually do not have an absolute minimum, because why? It's going down forever and ever. See that arrow? If that arrow weren't there, if that was like a solid point right there, then the absolute minimum would be -3 when x is -4. But because the arrow's going down, this picture has no absolute minimum.
It wouldn't say it's negative infinity and
No.
infinity.
No, it has no minimum.
So it's not. Wait, why isn't it the 3, -4, like the -3, -4? Or -4, -3?
Because look at the other side of the picture.
So,
See that arrow?
yeah.
So what does that arrow mean?
Oh.
Is it gonna go down lower than
Okay.
that point you're talking about?
Yeah.
All right, so let's look at example 2. Find and classify each type of extremum for picture A. Relative minimum, none. Remember, a minimum is where you change from being concave up. No, that's not right. Where you change from going decreasing to increasing. Decreasing to increasing, that's a minimum. That doesn't happen in this picture. Relative maximum at x equals 1. Absolute minimum, obviously none. We didn't have a relative, so no absolute minimum. We have an absolute maximum. Maximum value is 3, and it happens when x equals 1. All right, you do the next 2. You do B and C. Are you willing to share your answers for B? Charlie?
For relative minimum, I got x equals -2. For relative maximum, I got x equals -4 and 3. And then for the absolute minimum, there is none because there's an arrow going down. And for the absolute maximum, it's 2 and x equals 3.
Oh, I matched him exactly. What about you? Anybody have any issues with that?
What was the maximum?
Is relative maximum, there were 2 of them, at x equals 3 and -4. All right, anybody willing to bet 100% like Charlie with C? Yeah, Quinn?
My relative minimums at x equals -3 and 3. Relative maximums at -4, 0, and 5. Absolute minimum at -3 when x is -3. And absolute maximum at 4 when x is equal to 5.
Yes. Well, the quizzes are that good. We're doing great. Everybody okay with that? Good. All right, fun facts about polynomials. Between 2 real zeros of a polynomial, so think about what that means. Zeros are like here and here, with x-intercepts. So what can you tell me? What are you guaranteed to have between these 2 points? What do you have to have? Annie?
relative maximum or relative minimum?
Absolutely, because these 2 points, this is a polynomial, so they're not gonna be connected with a straight line. They're either gonna be connected like this or like this. So in between them, there has to be a relative max or relative min. Beautiful, all right? How about the next one, number 2? Patrick?
Polynomials of even degree must have either a global maximum or global minimum,
Absolutely. Why is that, Patrick?
because both of the end behaviors are either going up or down.
Exactly. So even degree polynomials, I'm gonna tell, did you have Miss Livingston last year? I'm gonna tell her you remember that. Even degree polynomials have end behavior that's either up, or down, right? Same direction. So if you have some polynomial that's going up on both sides, doesn't it make sense that somewhere in between them, there has to be the absolute lowest point? It might be all like this, but someplace there's gonna be the absolute lowest point. Very, very good. Very good. All right, next page, points of inflection. All right, we already talked about this. A point of inflection occurs when a function changes from concave up to concave down or vice versa. At a point of inflection, the rate of change of a function changes from increasing to decreasing or vice versa. And that makes sense because if the concavity is changing, obviously the rate of change is changing, right? Okay, example 3. Use the graph. Find any values of x where it looks like we might have a point of inflection. So what do you think?
-1 and -1.
I heard somebody say, what?
-1 and -1.
So the point -1 comma -1? I could buy that, could you? Are there any others? One, -1? Could you live with one -1 as a point of inflection also? Okay. For each of the following intervals, determine if the rate of change is increasing or decreasing. Explain your reasoning using the features of the graph. This is review. You just took a quiz over this. 3 to 4. That interval right there, from 3 to 4. What do you think? Charlie?
It's increasing.
Why?
Because it's concave up.
Awesome. To make my heart sing. All right. -4 to -3. Decreasing because, or excuse me, increasing because it's concave up. -1 to 1. Decreasing because we're concave down. And 1 to 2. Increasing because we're concave up. All right, example 4. Looks like we need a calculator. This equation tells us how many cars are in the parking lot at a given time. At what time does the number of cars in the parking lot change from increasing to decreasing? Take a minute, talk that over with your partner. See if you can figure that out. You'll need a calculator.
No, I do. Yeah, but how do you know when it's, the inflection is? And then I'm saying, is there a thing that you can do? I put it in, I know, yeah, I put it in 0 to 3. You know what I'm saying? And then,
Any group got an answer? Leo, did you guys get an answer? What'd you get?
3.446.
2.446, that's what I got too. How come? What'd you guys do? You graphed it and then found the maximum, and why did you change the maximum? Because at a maximum, we go from being increasing to being decreasing, right? So you found the maximum, very, very good. All right, 1.4, we'll review on Monday. Let's turn now to the back of the next page. Can we predict stop values? The back of that page. The back of that page. Okay, so table number 1. We're on the back of the stock values page. Okay, table number 1. Look at your X's. Are your X's equal size intervals? Okay, so now we're gonna make a decision based on differences only, okay? So let's find the first differences in the Y's. So go ahead and find those first differences. Oh Lord, you might need a calculator, maybe not. Are we linear? No, right? Because if we were linear, those would all be the same. All right, let's see if we're quadratic. Are we quadratic? No, because if we were quadratic, we would expect these to all be going up by the same amount. All right, let's go one more. Okay, guys, these were the first differences. These were the second. These were the third. These were the fourth. Hold up. Your fourth differences match. See that? So that means your polynomial is a fourth degree ordered polynomial. Yep. Yep. All right, I'll see you tomorrow. And we'll pick up here. And we'll have 1.4 ready to go on Monday.
Tyler, bro.